Next is the operation and maintenance section. Here, we first input the actual realized input flow of fecal sludge to the plant, expressed in cubic meters per day. It is important to recognize this parameter as it is an indicator of the quantity of sludge currently treated at the plant. It can be calculated by measuring the sludge volume in transport tanks brought to the treatment site, or by measuring the pump flow rates and duration of usage during desludging. The examples on how to estimate the sludge volume received by the plant can be accessed by clicking the green information icon within the text input box. The percentage reduction in total solids, which measures how much the total solids concentration decreases after the treatment process, is an important indicator of the treatment performance. For drying beds, this parameter is important to estimate the volume of dried sludge that needs to be removed from the sludge treatment facility. You can find examples of how to calculate total solid reduction by clicking the green information icon in the text input box. Next, similar to the TS, we need to define the percentage of COD reduction, another performance indicator. The reduction of COD measures how much the treatment process reduces the COD concentration. The COD is an indirect measure of organic matter content. The discharge of organics into natural water bodies can lead to oxygen depletion, harming aquatic life and damaging ecosystems. Another important performance indicator is the reduction of fecal coliform. Fecal coliforms are pathogenic organisms that can cause diseases. They are an indicator of fecal contamination, which means that other pathogens may be present. E. coli are part of the fecal coliforms that can be tested. They are usually expressed in colony-forming units per 100 milliliters volume of solution. The reduction of fecal coliforms is related to the difference between the fecal coliforms concentration of the influent entering the fecal sludge treatment site and the fecal coliforms concentration of the effluent exiting the fecal sludge treatment site. We then are requested to enter the operating expenditure, or OPEX, expressed in US dollars per cubic meter of real input flow. This includes all the costs that are related to the day-to-day operation of the treatment plant, such as energy, labor, maintenance, chemicals, and consumables. The OPEX indicates the economic efficiency of a fecal sludge treatment system as it is a crucial indicator towards the sustained and efficient operation of the treatment system. Next, we are asked to define the resources required by the plant for its operation by ticking the boxes that apply. The listed resources include chemicals, electricity, engine, and water. However, if there are any additional resources that apply, we may add further indicators accordingly by clicking the plus button in the input box below. Defining the required resources can assist in deciding if a particular treatment solution is suitable for a specific context, as the cost and complexity for execution will depend on the locally available resources. After this, any detailed information regarding the operation and maintenance of the plant is to be entered into the text input box. Here, the information entered should provide an overview of the operation of the treatment plant and measures taken for its regular maintenance. For example, parameters including reduction rates of BOD, TN, or TP can be included here to demonstrate the effectiveness of various treatment mechanisms within the plant. Information concerning desludging procedures, operation and maintenance tasks, health and safety measures, and any difficulties faced during the daily operation of the plant are all relevant and encouraged to be included in this section.